Right, here we go again, paper 2, ladies and gentlemen. Hopefully the chapters are working at the bottom so you can skip straight to the question that interests you. Let's race through these first ones then. First thing to say about this, don't miss the first page, guys. Several of you just missed page 1. Oh. Okay, nearest hundred. So units, tens, hundreds, thousands. I like to draw a line after the one I'm rounding to. Now I can think about this 61 that's there. Is that rounding up to a 62 or staying a 61? So we look at the next number, it's an 8, so yes, it's going to round up. That 61 becomes a 62, but obviously the answer is not going to be 62 because the number was over 6,000 beforehand. We fill in the zeros, 6,200. Right, 0.7 as a fraction. Hopefully remember, as we go up this way, tens, hundreds, thousands, it goes down the other way, tenths. That is 7 tenths. Don't know why I didn't just write it over here. 7 tenths. Okay, 9 meters into centimeters. You need to know a few conversions for this. The first one is 1 centimeter is 10 millimeters. Then 1 meter is 100 centimeters, and 1 kilometer, 1,000 meters. So for this one we need meters in centimeters. Well, 1 meter is 100 centimeters, so 9 meters will be 900 centimeters. 3 times 4t. 4t just means times by t, so what this really is 3 times 4 times t. I can multiply them together, the 3 and the 4. Sorry, the 3 and the 4 give me a 12. So 12 times t, or more simply, 12t. Here's a list of these numbers. Which of these numbers is a multiple of 25? So I'll just change my focus for a minute. There we go. Which of these numbers is a multiple of 25? Actually, I'm just going to move my whole setup. Sorry to interrupt. A multiple of 25 means it is in the 25 times table. Multiple, you multiply them, lots of them, 25, 50, 75, 100. Factor is the other one. Factor goes into it. It is a factor of, like, in this case, 1, 5 or 25. But multiple, the big one, so it's 100. Okay. First sheet down. Some probability stuff, definitely high on our list of things we need to do. So, hold on, just need to clear my throat. Right, fair ordinary dice. That's the normal sort you see. It has the numbers 1, 2, 3, 4, 5 and 6 on it. It does not have a 7, so it is impossible to get a 7. You're never going to get one. Mark with a cross, so I'm going to put a cross at 0. It's impossible to get a 7. Chance that's an even number. Well, my numbers are 1, 2, 3, 4, 5 and 6. Which ones of them are even? 2, 4 and 6. Well, that's 3 out of 6 of them, or exactly a half of all the numbers. So right in the middle, evens. Okay. Question 7. Triangle. Measure the length of AC. I don't know how yours printed out. I think yours was about 9. When I measure mine, it's 8.8. I think yours might have been 9. I can't remember. Sorry. Measure the angle. Okay, a couple of things about angles. First thing I'm going to do is this bit here. Oh, that's annoying the way that's. There we go. Needs to go exactly on the cross. Not like this, a little bit off, not down here, not up there. It's not that bit, it's there. And I've got to line this 0 up there. So I'm going to line that 0 up and put that cross there. There we go. And now my 0 goes there, so the whole angle goes right round past 90 up to nearly 110. How many degrees short of 110 is it? It's really difficult for me to see unless I'm looking through the camera. That would be 105, so it's about 107. I think it is 108 from memory. Now these are all plus or minus 2 millimeters, plus or minus 2 degrees. So you could have had anything from 106 to 110, and I allowed anything 2 millimeters either way. Like I said, I think yours printed slightly different to mine. Actually, I think yours might have been spot on 9 centimeters long. But the key point is AC is that length there. Okay, a different triangle. QP equals QR. QP, that's that length, is the same as QR. Those two are the same length. It's got two that are the same. They're very generous with this spelling here, but it's isosceles triangle. I used to live up in Yorkshire near a place called Skipton, so the way I always remember it is I sat on Skipton Castle eating lettuce and egg sandwiches. It's weird enough that I've always remembered it. I'm terrible at spelling, but you had to get anything that was close to that. I had a lot of equilaterals. Equilaterals being the ones where all three sides are the same, not an isosceles. Isosceles, two sides the same. Okay, that's that page done. On to question 8. Diagram shows 3 motorway services P, Q and R on a map. Map has a scale of 1 centimetre is 4 kilometres. Work out the real distance from P to R. So this is 8 centimetres long. 1 to 4 is our ratio. That's centimetres to kilometres. So 1 centimetre on the map is 4 kilometres on there. So I need to work out what 8 of them is. So to do that, I times both sides by 8. I get 32 kilometres. So that distance there is 32 kilometres. This distance here is 16. I can get from 8 to 16 by doubling it. 16 is 64 kilometres. Right, so now I've got 32 kilometres and 64 kilometres. So the whole way will be those two added together, which was 24 centimetres, or add them together, 96 kilometres. First 5 turns of a sequence. So is this one of the ones where they're going up by the same amount each time? Add 5, add 5. Oh yeah, they're all going up in 5s. Yep, that works. So the next turn of sequence will be 5 bigger than that. 28. Read the question. Some of you quite early in the paper decided that what you're going to do is find the nth term or something like that. It's not, just as the next term of the sequence. Next one along there would have been 28. The ratio of the second term to the fourth term. So second to fourth, 8 to 18. Second term, fourth term, 8 to 18. That's worth 1 mark, but it's worth 2 because I've got to give it in its simplest form. Can I simplify this down at all? Well, 2 goes into both of them. I can halve them both. Gets me 4 to 9. That is as simple as it gets. 4 and 9 have no common factors other than 1. So 4 to 9 was your answer. Cost of parking for 4 hours. Number of hours, 4. So I'm just going to draw a line up here. How much would that have cost? Oh look, exactly 6. You didn't need to draw these lines, but they're useful. £6. Justin drives into the car park at 8 in the morning. When he drives out of the car park, he has to pay £9. What time does he leave? Well, £9. How long would that have bought him? 8, 9. So going this way. And the last one, I was heading that way. This one, oh right, so Justin was there. £9 is 6 hours. Justin was there 6 hours. 6 hours after 8 in the morning is 14, or 14 o'clock. If you want to change it into, oh sorry, I've just realised you can't see any of this. If you want to change that into 12-hour time, it would have been 2 p.m, not 4 p.m, not 14 p.m, 2 p.m, or 1400 hours. Question 11. Most people spotted how to do this, but not everyone. I was upset nobody drew that extra part of the table that I've always suggested you doing. Total weight. Well, one person at 40 kilograms, they're very small, that's 40 kilograms. Two people at 50 kilograms, or two 50s is 100. Four 60s, 240. You got calculators for this, and I'm not going to spend ages talking about how to do it. 5 70s, 350. 3 80s, 240, and 190, 90. Now I just need to add them all together. Where's my calculator? Right, 40 plus 100 plus 240 plus 350 plus 240 plus 90, 1060 kilograms. So total weight 1060 kilograms. Bunch of light people. That's enough. I've shown that it's less than 1200 because I've shown what it is. I don't need to write a big old sentence about it or anything like that. Just that. Okay, shape A is reflected in a mirror line to give shape B. So, you don't have mirrors in the exam. My recommendation for ones like this is turn it until you can sort of see what's going on. If it helps, this may help some of you, it may not. Join these up gently. I should use a pencil for this, but I don't have one to hand. I can sort of see those three lines. Then find halfway between each of them. Halfway's there, halfway's there. The mirror line should be halfway along the whole lot. So the mirror line is this line here. There's your mirror line. That shape there, if I sort of flipped it over, goes on top of the other one. It should always be the same distance away from that line everywhere. There's the mirror line, diagonal one. Slightly awkward, but I think you can all manage that. Let's practice some reflections. Second one, lots of you sort of spotted what he's done wrong, but didn't explain it well enough. He's asked to reflect this shape in the x-axis. So he should have had it down here. Drawing that and saying it should be there is actually enough to get the mark. Lots of you went, he should not have reflected it in the y-axis, or he reflected it wrong. That's not an explanation. You need to be a bit more specific than that. Explain the mistake he made. He reflected in the y-axis. Oops. Instead, that's enough, I think. But it's the y-axis instead of the x-axis. Whoops. Okay, 50 teachers in school. This is 1/16 of the total number of people in the school. Work out the total number of people in the school. Well, the simple things to times by 16. I like these ratio tables to explain things, though. So fraction people. So 1/16 of the people is 50. So to get to 16/16 of the people, I'm timesing by 16. So 50 times 16 gives me 800 people. There's 800 people in the school. Lucky people. Imagine just 16 people in a class, eh? It will be a lot easier for us. Okay, this was quite tough. These do come up occasionally. There's two different ways of doing it. We can do the volume method, where we work out the volume of this and divide it by the volume, divide them by each other, or we can work out how many are going to fit in. It's not to scale very well at all. So let's do the volume method. Let's do that one here. So the volume method is find the volume of the packet, find the volume of the box. So box volume is 72 times 48 times 24. So 72 times 48 times 24. That's big. It's got a volume of 82,944 centimeters cubed. The packet volume, now we've got to spot early that these are millimeters and these are centimeters. 80 millimeters is 0.8 of a centimeter. So I'm doing 0.8 times 0.6 times 0.2. 0.8 times 0.6 times 0.2 gets me 0.096 centimeters cubed. That's not very big. So this has got huge, loads of them, 82,000 centimeters cubed. And this is less, like far less than a centimeter, less than a tenth of a centimeter cubed. So to work out the total amount, I can do the box divided by the packet, which is 82,944 divided by 0.096, which gets me 864,000. Can fit a heck of a lot in there. A heck of a lot of the packets inside the box. Nearly 1 million. In fact, that seemed so much that I realised, hold on a minute, I must have done something wrong. I have. 80 millimeters is 8 centimeters, 60 millimeters is 6 centimeters, and 20 millimeters is 2 centimeters. Right. Can that? Everyone makes mistakes. Let's do the packet volume again. Packet volume is 8 times 6 times 2. 8 times 6 times 2 is 96 centimeters cubed. Right. So the box divided by the packet is 82944 divided by 96, 864. So we can fit 864 of these little ones into there. The other way of doing it is thinking about dividing this box up. So how many of these can I fit along there? 72 divided by 8 is 9. So I can fit sort of 9 of these boxes going along there. I am going to try and do it. 1, 2, 3, 4, 5, 6, 7. Ah, damn, 8. Okay. Anyway, so I can fit something like that. 3, 4. Going along that way. End on end. Then going this way, I've got 48 divided by 6. How many would fit going along that way? 48 divided by 6. I don't know why I'm using my calculator. I'm getting lazy like you guys. Means I can fit 8 of them going along that way. And then how many going up there? It's 24 centimeters high. And each of those are just 2 centimeters high. So I could fit 12 of them. So basically I fit 12 boxes, 12 layers. And each layer is 9 boxes long and 8 boxes wide. So that's 72 layers. And then I can do 12 of them. 12 layers of 72. 9 times 8 times 12 gets me, oh, guess what? 864, which is the correct answer. Bit awkward. They often do this, how many of one thing can fit in another one. The volume method might be the easiest for you unless you do something silly with your unit conversions that I do. I'll just point out the biggest mistake that people make on this, which is finding one of them in millimeters squared and the other one in centimeters squared. If I just draw, cubed, 1 centimeter cubed, I'll squeeze it in down here. 1 centimeter cubed is 10 millimeters high, because it's 1 centimeter, 10 millimeters wide, 1 centimeter, and 10 millimeters long, 1 centimeter. So that's 10 times 10 times 10, 1,000 millimeters cubed. Converting between units of volume is risky. Okay, it's risky. Things go wrong. Try and do all your conversions in lengths before you calculate volumes. Okay, that's 14. 15, a dice and a spinner. Charlie throws a dice once and the spinner once. Is he more likely to get a number less than 3 on the dice or a number greater than 5 on the spinner? Well, on the dice, we've got a number less than 3. Well, my options on the dice are 1, 2, 3, 4, 5, and 6. A number less than 3 is that and that. So that's only 2 out of 6. Probability is 2 out of 6. That's on the dice. On the spinner, got more things to have chosen from, 1 through 8. And a number greater than 5 is those 3. So that's 3 out of 8. What's bigger, 2 6 or 3 8s? Hey, guess what? I've got a calculator. I'm going to use it. 2 divided by 6 in decimals is 0.33333. Dot, dot, dot. And 3 8s is exactly 0.375. Well, which of those is bigger? 0.375. So is he more likely to get that or that? So the answer is greater than 5 on the spinner is more likely. Crikey. When I'm trying to watch the video and writing at the same time, I do some very funny stuff. Right, greater than 5 on the spinner is more likely because 0.375 is bigger than 0.333. Lots of you got to the 2 6 and 3 8s, but didn't do anything to compare them. I mean, if I was doing this on a non-calculator paper, I'd just make them both out of 24. 2 6. Oops. Let's try it again. 2. Oh, for goodness sake. Let's do it down here. Start fresh. 2 6 is 8 out of 24. Multiply them both by 3. And 3 8s is 9 out of 24. Multiply them both by 3. So you can see 9 out of 24 bigger than 8 out of 24. 16. Paolo drives at an average speed of 56 kilometers per hour for 1 hour and 45 minutes. Work out the distance he drives. Now this could come up on a non-calculator paper, but it hasn't. It came up on a calculator paper. 1 hour 45 minutes. That is not 1.45 hours. 45 minutes. You guys probably recognise it in your head straight away. 1 hour 45 minutes is 1 3/4 of an hour, or 1.75 hours. Right. Now, speed, distance, time. Next, you need to remember the triangle. Speed, distance, time. Speed is equal to distance divided by time. What does they want? Oh, they want distance, so I cover up my D. Distance equals speed times time. D equals S times T. Right, so that's 56 times by 1.75. 56 times 1.75, 98 kilometres. He's gone 98 kilometres. Does that sound reasonable? It's going to be a bit less than double it, isn't it? Because if he was doing that for 2 hours, he'd do 112. It's a bit less than that. Sounds reasonable to me. This wasn't easy. We did do a couple of lessons on this, and well done. A few of you did get it. Right. The mean number of seats per cinema is 380. That means if I add up A, B, and C, and then I divide it by 3, I get 380. I find the mean of all 3 cinemas by finding the total and dividing by 3, and I get 380. So, I know some of these things. Actually, I can make this a bit simpler. I know A is 350 and B is 250. 350 and 250 is 600. So I know this is actually 600 plus however many are in C divided by 3 is 380. Now I've got an equation I can solve. Times both sides by 3 to get rid of that 3. So 600 plus C. 380 times 3. Don't know why I'm using a calculator. 1140. Almost got C on its own. I need to take away 600. Take away 600. So I get C equals 540 people. 540 seats. Let's just double check that works. And let's find the mean of 250, 350 and 540. So I do 250 plus 350 plus 540. So that gets me that many seats. And because there are 3 cinemas, I divide by 3, I get 380. Great, so that's what it must have been. So being given the mean and having to work backwards is a little bit tough. It involves a bit of equation solving. Some of you sort of had the logic. You don't want to find the mean of these two to start with. You need to find the mean of all of them added together. Right, on to 18 already. Asher has bought a lot of cans of cola. Cans are sold in packs. There are 12 cans in each pack. Each pack costs £3. Work out the total cost of the cola she buys. So 180 cans. And she's bought them in 12. So I'm going to have to do 180 divided by 12 to find out how many packs she's bought. That's 10, 15, isn't it? So that means she's bought 15 packs. Writing down what I'm doing as I go, not just to help the examiner, but to help me. 15 packs and £3 per pack, so 15 times 3. She spent £45 on Coke. Right. Ethan buys a box. 24 cans of lemonade for £7. There are 330 millilitres lemonade in each can. Work out the cost of 100 millilitres of lemonade. There's quite a lot going on here. So first off, I'm going to work out, and a lot of you did, how many millilitres. He's got 24 lots of 330. So the total fluid he's got is 24 times 330. You didn't have to start this way. This is my recommendation. So he's got 7,920 millilitres of lemonade. And it cost him £7. So millilitres, pounds. Actually, because it's asking for the answers in pence, I'm going to do it in pence. So 7,920 millilitres is 700 pence. The question is, what's 100 millilitres in pence? So I'm going to get from this to this. There's a couple of ways you could go about it. I like the idea of going via 10. So if I can get from 7,920 to 10, well, I do that by dividing by 792. So I'm going to have to do 700 divided by 792 to get there. Oh, gets me something ugly, 0. Right, how am I going to deal with this? I'm going to write down the first few bits of that, but I'm not going to round it too much. I've got that. Right, now to get from there to there, I've got to times by 10. Times by 10, which gets me like 8.838 ... So that's what 100 millilitres will cost. Well, rounding that to the nearest penny, 9 pence. 9 pence is what it cost. Lots of people were tempted to divide by 7 because it gave nicer numbers and things like that. It seemed like the right thing to do. But you're not dividing by 7 here. You're dividing by 700. You're dividing by this side to get there. And the ratio table helps you figure that out. Find out what you know and what you're looking for, and then work out how to get there. You've got to calculate. You can do all sorts of complicated things. You've just got to work out what to type into it. Frequency trees, mostly done well. We're going to use this information to complete this. Right, 150 have a car. Well, that tells me this one straight away. Cross it out because I've used it. Oh, actually, I can work that out. If I know 240, there are 240 people in total, 150 there. Don't have a car, must be 90 because they have to add up to make that. 110 have a bicycle. That doesn't help me at the moment because I know that's both of those added together is 110. Maybe it'll help me in a minute. 65 of the people who have a bicycle do not have a car. Do not have a car, have a bicycle. 65, right? If that's 65, then the rest of the 110 have to go up there. So that's what that 110 tells me. 110 take away 65. Again, I'm using a calculator even though not divided by. 110 take away 65. That's 45 people there. Now I know there's 110 with a bicycle. How do I work out the others? Well, these two here have to make 150. So this one must be 105. And these two here have to make 90. So that must be 25. Right, what percentage of the 150 people who have a car also have a bicycle? So this is all I'm interested in here. This bit. I don't care about all of those people that don't have cars. All I'm interested in this. So it's 45 out of 150 that have a bicycle. 45 out of 150. Need to write that as a percentage. 45 divided by 150. Well, that's 0.3. How often have we turned 0.3 into a percentage? It's 30%. If you've forgotten how to get from that to a percentage, it's times by 100. 30%. Okay. On to question 20. Do this all in one go. Most of you got it right. Those of you that didn't probably didn't use the fraction button to do this stuff at the top all in one go. 25 minus the root of 43.87. Now go down to the bottom. 6 plus 2.1 squared. This should exactly map this, and you should do the whole lot in one go. This used to be a lot harder for me when I was a kid and we didn't have these fancy calculators that could do all this in one go, but hey, you do have this. So equals 1.76527923. Okay, reciprocal, something that very few people remembered. The reciprocal a number is 1 over it. 1 over 0.625. The reciprocal of 10 is 1 over 10. The reciprocal of 2 is 1 over 2. The reciprocal of 0.65 is that. So 1 divided by 0.625 gives me 8/5. You can write it like that, or you can write it as 1.6. Both get you both marks. Don't bother writing both like I have there. I'm just writing that because I know a lot of you can look at this. 60 is a product of its prime factors. 60 has it split up. I'm lazy. I often go for a 2 when I'm feeling lazy. 2 times 30. 2's prime. 30 isn't. 30, that's nice. That's 3 and 10. 3's prime. 10 isn't. 10 is 2 times 5. So I get 2 and 5. Finally, for my last mark, I need to write them as a product. 2 times 2 times 3 times 5. That's good enough. If you want to be really like posh, 60 equals 2 squared times 3 times 5. Okay, here's the trick. This is on a calculator paper. I'm going to type 60 equals, so my answer is 60. Now I'm going to use this button, fact. I've got to press shift, then fact. Oh my goodness, it's done it for me all in one go. 2 squared times 3 times 5. It did the whole prime factorization for me. You can do that with any number. Let's do 250. I need to press equals, so it's there, and then shift fact. Oh, it's 2 times 5 cubed. What about 3,600 equals fact? That'd be 2 to the power of 4 times 3 squared times 5 squared. Most of your calculators have this fact button on it. If you do, and you're in a calculator paper, use it. Okay, great. If you can do this, do it. We can remove mistakes and check using the calculator. Okay, this is 1 mark. You don't need to write an essay, and most of you sort of figured out that those of you that did spot it was wrong explained it quite well. But number of red counters, number of blue counters is 1 to 2, so there should be twice as many blue as there are red. That's what that ratio means. We need to have double the number of blue and red than there are red. If there's 24 counters, it must be 24 red counters, because that's half of 48. We don't want them to be half. So, is Helen correct? No. That would mean equal blue and red counters. Because I'd have to have 24 red and 24 blue. Not a ratio of 1 to 2. It needs to be a ratio of 1 to 2, and it's not. That half would give me a ratio of 1 to 1. I don't need to go on to be that complicated and clever, though. I just put, that's not right, that's the same number. Okay, getting closer to the end. This means less than or equal to 2, so n is allowed to be, that means greater than or equal to -2. So n can be -2, -1, 0, 1, 2, 3, 4. Is it allowed to be 5? No, that says less than, not less than or equal to. So they are all the numbers that n can be. You don't need to write them all out. I just thought it might help to demonstrate them. Well, I missed out the fact it's an integer, so it has to be a whole number. It can't be a half or minus a quarter. 0 is an integer, by the way. Write down the greatest possible value of n. Well, it has to be 4. Can't be bigger than 4. Right, this was worth 2 marks. One was just clearly indicating it's some between 1 and -4. The other thing you had to remember is if it's less than, then it's a circle. It's not allowed to equal 1. So we draw an empty circle. It is allowed to equal -4, so we draw a filled-in circle. And it can be any of the numbers between them, so we draw a line between 1 and -4, including -4, not including 1. So that's how you indicate an inequality on a number line. Solid dots for the less than and equal to, hollow dots for the less thans. Solving an inequality. Lots of you seem to panic. Now, this doesn't work 100% of the time, but the easiest way to think about this is as an equation. It's not an easy equation either, but let's just imagine it was equal. So I'll deal with the inequality afterwards. I'm going to add 4 to both sides. So I get 2/5 g is 10. Now I need to get rid of that 5, so I'm going to times both sides by 5. That leaves me with 2g is 50. Then I'm going to divide both sides by 2, so I get g is 25. But I don't want to leave it as g equals 25 because it was a less than all the time, so g is less than 25 is our answer. Now this changing it for an equal sign doesn't always work, and I'll be doing some inequalities work with you, but for the time being I want you to, when you see it, think it's just like an equation. There are some exceptions, but just imagine it was an equation, try and solve it. Admittedly, this was a tough equation. It was 3 steps and we had a fraction in it, so there's a lot of tough stuff going on. But treat it like an equation. Do the same thing to both sides as you go along. But all the way, it's been a less than sign. But you can treat it in almost all circumstances as an equal sign. Right, the area of this triangle is bigger than the area of the rectangle. Work out the value of x. Now this gives us a tough equation. I'm going to set things out first off. First off, it would be useful to find area of the triangle. So the area of the triangle, how do I work out the area of the triangle? Base times height divided by 2. So base is 8, height is 6x. So I'm going to have to do 8 times 6x divided by 2. Yeah, that's 48x over 2. 48 over 2. Right, that's 28x. That's the area of the triangle. That's 1 mark already out of my 4. That's the area of the triangle. Right, what about the area of the rectangle? Area of a rectangle, length times width. So that's 5 times by 4x minus 1. Note I use some brackets here. The reason I use the brackets, everything needs to be multiplied by 5. It's 5 times 4x and 5 times minus 1. So that's 20x minus 5. Right, I've got the area of the rectangle, I've got the area of the triangle. Now I can form an equation using what it tells me here. The area of the triangle is 10 centimetres more than the area of the rectangle. So that is equal to the area of the rectangle plus 10. So 28x is equal to 20x minus 5 plus 10. This is the same as that, but bigger. So these are now the same. If I add 10 to the area of my rectangle, it's equal to the area of my triangle. I've got an equation I can solve. I'm going to start by just combining those two things, make this a bit simpler. 20x plus 5. Next, I'm going to get my x's in the same place. I'm going to take away 20x from both sides. If you need to revise some solving equations, do so. I get 8x equals 5. Finally, to get x on its own, I'm going to divide both sides by 8. I get 5 over 8. So x is 5 over 8, or I think that's 0.625. We could go through and check this afterwards. It might be worth just looking at that actually. I've got an answer. Is it right? Well, the area of my triangle would be, let's see, so 6 times 0.625, 1504, so that's 3.75. I'm actually going to write this on a separate sheet of paper for the moment. There we go. So that triangle would be 3.75 high and 8 wide. So what's the area of that? Base times height divided by 2. That gives me an area of 15. Okay, so what about my rectangle? Well, if x is it's still got a width of 5, x is 0.625, and 4 times 0.625, so 2, take away 1, right, I get 1.5 as the height. So 5 times 1.5 gives me 7.5. Oh, that isn't 10 bigger than that. Give me a minute to just check my working. Damn, spotted it. Half of 48 is 24x. So that should have been 24x there. That should have been 24x there. Then when I took them away, that should have been 4x there. Oh dear. Then I divide by 4. Whoops. So that means my should have been 5 over 4. Or 1.25. Good job I went back and checked it. I'd like to pretend that was deliberate, but I just made a basic error there. I'm going to check it again. You can skip forward if you're bored. So I've got a triangle. That is 6 times, what did I say it was? 1.25 for the height and 8 there. So 6 times 1.25. Try and get that in a place you can see it. 6 times 1.25. So that's my height times by 8 and then divide by 2. Okay, I get an area of 30 for the triangle. My rectangle is 5 wide and 4x, so that's 4 times 1.25 minus 1 for the height. So 4 times 1.25 minus 1, so that's got a height of 4. And width of 5, 4 times, 20. Area 20, area 30. Yeah, my triangle is 10 bigger than my area. I'd love to say I deliberately made a mistake there and then went through and checked it and found it, but I just thought it would probably be a smart idea to check it. I'm just used to doing these things. Do check you're working. For big questions like this, worth a lot of marks, if you've got a bit of time, it's worth just subbing it back in and seeing whether you're right. Make you feel good about yourself if you know you got it right as well. Okay, last few pages. Last year, the family recycled 800 kilograms of household waste. 50% of this waste was paper and glass. So paper, glass, 12 to 7. Right, calculate the weight of the glass the family recycled. So if I can find out the total, I can divide it up in a ratio of 12 to 7. So first off, I've got to find 57% of 800. Now, you guys have done so well at doing non-calculator percentages. Seems like we've forgotten how to do calculator ones. The easy way to find 57% of something is to times by 0.57. Times by 0.57, we get there in one go. 800 times 0.5, oops, 800 times 0.57, 456 kilograms. If you did decide to do yourself a table, grand, I have been encouraging you to do them. 100% is 800, and I want to get to 57. Go via 1. Go all the way down to 1. Divide everything by 100. 800 divided by 100 is 8. And then times it. Divide by 100. Times it by 57. You've got a calculator. You don't need to do the easy ones anymore. You can do them. You can just plug 8 times 57 into your calculator. And it should also get you 456. Whichever method you did, that's your first mark. Right. Now I've got to divide this up. I've got to split this up into the ratio 12 to 7 for paper and glass. And this is what I'm interested in. If I can work out what this 7 is, I've found the glass. So, first off, to divide something into a ratio of 12 to 7, find out how many total parts there are. It's as if there were 19 parts. How much is each one worth? 456 divided by 19. 24. So it's 24 kilograms. I've taken all their waste and divided it into 90. Well, all their recycling stuff. They've recycled more than half of what they've used. Well done, guys. And they're taking their 556 and divided it up into 19 piles of 24. 12 of those piles of paper, 7 of them are glass. So this will be 7 times 24. 168 kilograms of glass. If you're interested, you can work this one out as well. 12 times 24, that's 288 kilograms of paper, 168 kilograms of glass. Right. Does that sound about right? Well, it's less than 800, that's a great start. And it's got to be a lot less than half of that, because they recycled a little over half of it, and then about a third of that, 7/19 was glass. So yeah, sounds about right to me. Number D is rounded to one decimal place. The result is 12.7. The way I taught you guys to do this is that the number's 12.7. It's not big enough to become 12.8, and it's not small enough to become 12.6. It's somewhere in this region here where it rounds in to 12.7. So it can't be closer to 12.6 and it can't be closer to 12.8. So these boundaries here must be halfway between these two numbers, 12.65 and 12.75. So it's 12.65 and 12.75. It's got to be bigger than, or it can actually be 12.65 because 12.65 rounds up, but it's got to be smaller than 12.75. If it was 12.75, it would have rounded up. So these little number lines are my best recommendation for this one. Well done on this one, guys. I think this is a tough question, but a lot of you got it right. It uses compound interest. It doesn't say the word compound interest anywhere. It just assumes that, interest is compound unless told otherwise. And a lot of you remembered that. So, if you can remember the formula, that makes things easier. If not, we can do it a different way. So, 150,000 increases by 4% each year. So I'm going to work out Tamsin, because it's 2 years worth. I'm going to work out Tamsin's house, and I'm going to work out Rachel's house, and then I'm going to draw a conclusion. So Tamsin's, the easiest way to increase by 4% is to do 150,000 multiplied by 1.04. Multiplying by 1 means it stays the same. Multiplying by 2 is a 100% increase. Multiplying by 1.04 is a 4% increase to this amount. You could work out 1% and then add it on as well, but this does get a lot easier. 150,000 times 1.04 means that after 1 year, her house is worth £156,000. It's increased in value by £6,000. For the second year, it should be a 6. I can take that and multiply it by 1.04 again. So I'm going to take my answer, multiplied by 1.04. I get £162,240. More money than I can even dream of. Amazing. Right. Well done, Tamsin. That's how much your house is worth over 2 years. There is a shortcut. You can do the whole lot in one calculation by multiplying by 1.04 squared. Okay, Tamsin done. Rachel, her house is worth more to start with. £160,000, but she's increasing by a smaller amount. 1% would be 1.01. I want 1.5%, so it's got to be an extra 5 at the end there. So 160,000 times by 1.015 means that after 1 year she's got a house worth £162,400. That's already more than the value of Tamsin. So I don't even need to do this second one. I am going to though. To find she's got at the end of it. Her house is worth £164,836. At the end of 2 years, whose house has greater value? Rachel's house has greater value. Boom, done. Okay. Last question. 5 graphs. So there's a few different types of graphs we need to remember. These ones are called quadratic graphs. Ones that have a squared term in them. If it's a positive squared term, it looks just like this, a parabola. If it's a negative squared term, it goes the other way around. Quadratic graph like that. So that is B. Cross B off because I know I've done it now. This is just a linear graph. It's not got a squared term. It's not got a cubed term. It's a linear graph. It's the y equals mx plus c. It's got a positive gradient. So linear. It's going up. This is also a linear graph here. It's not got a squared term. It's not divided by x. But that one's going down because it's got a negative gradient. So I've got a line going up. I've got a line going down. Line going up is D. Line going down is A. They're the main ones we come across. We've also done a bit on these, the ones with the cube terms in. They're called cubic graphs. They look like this. They're the wobbly ones. Goes up and down. So that's a cubic graph, E. And these, the 1 over x graph, obviously going to be the last one, a reciprocal graph. That's C. Done. Right, I hope this video's helped, guys. like and subscribe or whatever. But, right, paper 3 coming tomorrow.